Hi there. In this video, we will talk about acids and bases for organic chemistry. This is a very important topic in organic because 90% or more reactions in organic chemistry occur between acids and bases. By acids, I mean electrophiles, and by bases, I mean nucleophiles. So about 90% of the reactions occur between acids and bases. That is why these topics deserve a special mention. And then we often get questions like deciding the strength of acids and bases, and we also talk about their pK values in questions related to JEE or medical examinations. Now, if you understand this topic really well, you will have a really good time learning organic chemistry and enjoy it because, as I said, 90% of the stuff is just acid-base reaction. Let's go ahead and start with the definition of acids and bases. So we will follow the Bronsted definition for acids and bases. So Bronsted is the name of a scientist who gave a theory, and the theory suggests that an acid is something which can lose a proton, and we write a proton as H plus because hydrogen ion has no electron, and so it is a proton. So acid is something which loses a proton, and base is a substance that can gain H plus or gain a proton. HA, this compound has an H with it, so it can lose that H and it can form H plus and A minus. These are the two ions that it can form. So this compound lost a proton, and so therefore it will be called an acid. Now if you take a look at the reverse process of this reaction, and let us draw the arrow like this. The species A minus gained a proton to form HA. That's why we call A minus a base. And because this HA and A minus differ only by an H plus, they are said to be the conjugate of each other. So we always have an acid base pair, where if an acid loses a proton, that is in the forward direction, we get the conjugate base, and if a base gains a proton, we get the conjugate acid. If we have HCl which loses a proton and forms H plus and Cl minus, then we say Cl minus is the conjugate base of HCl. And if we take a look at the reverse reaction, that is Cl minus plus H plus, and it forms HCl, then we say that HCl is the conjugate acid of Cl minus. So the difference between a conjugate acid base pair is of 1 H plus. Let's say I ask you to draw the conjugate base of OH minus. So to get the conjugate base, what you need to do is remove an H plus, and so you will get O2 minus. And in the same question, if I ask you to draw the conjugate acid of OH minus, then what you do is you add an H plus. So for conjugate base, you subtract an H plus, and for a conjugate acid, you add an H plus, and H plus and OH minus will become H2O. So that is the conjugate acid of OH minus. You can take more examples. If I give you CH3O minus and ask you to draw its conjugate acid, then all you do is add H plus and you will get CH3OH, which is the conjugate acid of CH3O minus. Let's take NH3, and this time I want the conjugate base. So for conjugate base, you subtract an H plus and you will get NH2, and because an H plus went away, there will be a minus charge and you will get NH2 minus. So that's how you get conjugate acid and conjugate bases. So how do we decide the strength of an acid? Let's go back to that example, and we have Ha, which gives us H plus and A minus. Now if this acid is strong, it will form a lot of H plus, and if it is weak, it will form less H plus. So whether it is a strong acid or not actually depends on its conjugate base. Now this A minus can be stable or unstable, and we know that any reaction wants to form stable compounds or species. So if the A minus ion or the conjugate base is stable, then a lot of H plus will be formed, and so we will have a strong acid because the reaction is moving towards the stable direction. And if it is an unstable compound, then this will be formed less, and therefore the H plus will also be formed less, and we will have a weak acid. So in order to decide a strong or weak acid, all you need to decide is whether the conjugate base is stable or not. Say you have HCl, that gives you H plus and Cl minus, and let's take H2O, that should give me H plus and OH minus. Now which of these is more acidic? We all know that HCl is a stronger acid than H2O. And how do we decide it? To decide, we compare the stability of Cl minus and OH minus. We compare their stability, and I will show you how to do that. But for now, believe me that Cl minus is more stable than OH minus, and therefore HCl is a stronger acid than H2O. So in the next video, I will show you how to decide which conjugate base is more stable and therefore which acid is stronger. See you.